of you from yesterday, please?
Yes, ma'am.
Thank you. So yesterday we went over solving rational equations. Shh, quiet down, please. Yesterday we went over solving rational equations where we had to get that common denominator for all three, multiply all of those fractions by that common denominator. So today is going to be similar, okay, except we're working with inequalities instead of an equation or an expression with that equal sign. So to solve rational inequalities, which are inequalities that contain one or more rational expressions, we're going to follow the steps below. So I have the steps laid out for you up at the top there. Okay, so step 1 is to state the excluded values. Okay, so we want to state, we're paying attention now, taking notes. Okay, state the excluded values. These are the values for which the denominator is 0. Okay, so you want to see where the denominator is equal to 0 because it cannot be 0. Second step is to solve the related equation. So that's what we did on the front when we were solving those expressions. Okay, so you're going to do the same process to solve. Step 3 is to use the values determined from the previous steps to divide a number line into intervals. So we need to make a number line with the answers that we find. Okay? Step 4 is to test a value in each interval to determine which intervals contain values that satisfy the inequality. So you need to pick numbers to the left of what you find and to the right and in between. So, looking at our example, we're going to go step by step here. So our first step is to find the excluded values. So where your denominator would be equal to 0. So I have a variable in this first one and this second one. When would that equal 0? When?
Possibly.
So if I say 3x equals 0, nope, divide by 3. Okay, so x can't equal 0. Because if I were to plug in 0 for x, that would make both of those denominators 0. Okay, so this is step 1. Okay, step 2 is to solve. What? Okay. How I got 0?
Yeah, you get 0.
I set the denominator equal to 0. So 3x equals 0. Solve for x.
So you just said it was that it equals 0?
Yeah, because it can't equal 0. Whatever you plug in for x, your denominator can't be 0. So it cannot be 0. That's why I wrote this slash through the equal sign. All right, step 2 is to solve the equation. So just like on the front, when we're solving this equation, we want that LCM. Okay? Or your least common denominator. So finding your LCM. You have 3x, you have an x, and you have a 9. Can you figure that out without writing everything out? What is it? 9 what? Okay, so your LCM is going to be 9x. That's the term you're going to multiply each of your fractions by. Okay, so we're going to take 9x times 4 over 3x plus 9x times 7 over x. I'm going to keep that less than sign. Then I have 9x times 5 over 9. Again, we want to multiply each of these terms by that so that your denominators cancel out. Okay, so looking to cancel things out here, I have 9x over 3x. Well, your x's will cancel, and then I still have 9 over 3. That'll turn into just 3. Okay, so I took 9 divided by 3. Next term here, I have 9x over an x. Your x's cancel. Last one, I have a 9 and a 9, and those will cancel out. Now I can multiply what I have left. For this first one, I have a 3 times a 4. So I have 12. I have 9 times a 7, 63. I still have this less than sign. And then I have 5x. Okay, I can combine 12 and 63. Okay, so I have 75 is less than 5x. Now I'm still trying to solve for x. So divide it by 5. So I have 15 less than x. Now I'm going to flip that around. Okay, so read this backwards. So I have x greater than 15. Okay, so I had to just flip that around so it's a little bit easier to look at. All right, so my step 3. Okay, next I have step 3. So we have to use our values from our previous steps here and plot those on a number line. So my values that I came up with are 0 and 15. Okay, so step 3. I need a number line. Okay, I need to plot 0. I need to plot 0 on that number line. And I need to plot 15. Okay, step 4 then. Okay, step 4, if you look at the table above, you need to test a value in each interval. Okay, so I just go from left to right. So over here, I need a value less than 0. Just going to pick -1. So if x is equal to -1, we're going to plug in -1 for all of our x values in our original. So we have 4 over 3 times -1 plus 7 over -1 is less than 5 over 9. Okay, so here I have -4/3 plus -7 over 1. It's less than 5 over 9. Now, in order to combine these, I need a common denominator. Okay, I'm just going to pick 9 because I want to compare it to this one here. So to get this 3 to 9, I'm going to multiply top and bottom by 3. So I have -12 over 9. Plus, I need to multiply top and bottom by 9 this time. So -63 over 9. Okay, then I have 63 and 12. That's -75. 9's less than 5/9. Okay, and I want to see if that statement is true. Okay, so is a negative 75/9 less than 5/9? Yes, because it's negative. So that's true. That means I could plug in any values that are less than 0. So I'm going to shade in that number line to the left of 0. Okay, because I just tested that point. Now I want to test a point in between 0 and 15. 1. So I'm going to plug in 1. Now you could plug in 2, 3, 4, 5, anything between 0 and 15. I just like to go for the easier numbers, such as 1. Yes. So, yes. So we're going to plug in 1 for our x values. Okay, so from here, I'm going to get the same denominator as with my -1. Okay, so I'll still end up with 12/9 plus 63/9 is less than 5/9. Now, except these ones aren't negative. Okay, so I'm getting that common denominator of 9, just like I did before. Can add them together. So I have 75/9 less than 5/9. That's wrong. Okay, so that one doesn't work. And then you have to test 16 or any number greater than 15. Okay, so I checked 16 just because it's right above 15. Okay, so I'm testing a point to the right of 15 now. So I'll plug in 16 for my x's in my original here. So we have 4/3 times 16 plus 7/16 is less than 5/9. Okay, so I have 4/48 plus 7/16 less than 5/9. Okay, I'm just going to make this denominator 48. Okay, so to get 16 to 48, I need to multiply the numerator and denominator by 3. So I'll have 4/48 plus 21/48 less than 5/9. So now I can add my numerators. So I have 25/48 less than 5/9. At this point, if you wanted to, you could plug your fractions into your calculator and see what their decimals are. Okay, and compare those. Okay, this one does work. 25/48 is less than 5/9. So I can shade my number line to the right of 15 because that's a true statement. Now, before you finish, I'm going to go back to where I said x is greater than 15, okay, when I was solving. So I need to also include this one right here. So I can say my x value can also be less than 0. Okay? So I found x is greater than 15, but I also had to test this interval here, and I found that any number less than 0 also works. Okay, so I have to include that in my answer. Okay, so it's the same process from yesterday, except you have to include that number line and test the values. Okay, so that same process, include the number line, test the values at those intervals. Any questions?